Well, hi there. We're going to have a very interesting look in this session at a very familiar name in mathematics, and that is Pythagoras and his theorem. And we're going to look at finding lengths of sides. Wow. And here's the man. Now that's an artist's impression of him, but really we don't know much about the man. He was, let me see now, I've written this down somewhere. He was born from 570 BC to 495 BC. He was a Greek philosopher, mathematician, and founder of a religious movement called the Pythagoreans. And most of the information about him was written down centuries after he lived, so very little reliable information is known about him and whether he actually did invent this theorem. So there you are. It's thought that some of his successors may have been responsible, but it's just not known. So how do you like that? Isn't that interesting? Yes, it makes you smile. Now, ladies and gentlemen, here is the feature attraction. This is what's known as a right-angled triangle, and so called because that angle there in the left-hand lower corner, just there, that is a right angle. What do I mean by a right angle? Well, I mean 90 degrees, and that angle is basically the same angle as the floor of the room you're sitting in now makes with the wall, or the same angle that the wall makes with the ceiling, okay? And the name they give to such angles and the surfaces which make them with each other, such as a wall and a floor or a wall and a ceiling, is perpendicular. Perpendicular, okay? So if you hear that term, you know it means a right angle. Now, it's 90 degrees, and the side opposite the right angle, that is this side here, is called the hypotenuse. Hypotenuse, and it's the longest side. It's opposite the right angle. What do I mean by that? Well, what I mean is that if you were to basically move from that right angle, out from the angle, you would hit the hypotenuse, just as I've shown you, okay? So that's how to tell that it's the side opposite the right angle. Just imagine yourself kicking a ball or a football or something out from that position where the right angle is, basically bisecting that angle, cutting it into two, and you would basically hit the hypotenuse, okay? Do you get that? Good, okay, and it is the longest side of the triangle. Always it is the longest side. Now, if you have a right angle triangle, as I've drawn there in the top right hand side, this triangle here is a right angle triangle. If you have a right angle triangle, and only if you have a right angle triangle, then the Pythagoras' theorem states that a squared equals b squared plus c squared. In other words, the length of the hypotenuse squared is equal to the sum of the squares of the lengths of the other two sides. That is b squared plus c squared. Okay, that's hypotenuse theorem in a nutshell. Okay, and we'll put a very special box around that because that is some theorem. It's used everywhere in everyday life as well as mathematics. Alright, so we're going to try and find x in this diagram here. Now, the first thing we note, we are asked to express our answer to one decimal place. Now, the first thing we notice is we've got a right angle just here in the lower left of this triangle. Okay, so that's good. That means we can use Pythagoras' theorem. Okay? Yes, it's a right angle. We can see that. And if we kick the football out from the goal, if you like, we will hit the hypotenuse. So that is the hypotenuse. This side here is the hypotenuse, okay? And it's opposite the right angle, which is here, okay? Now, x squared by our Pythagoras' theorem, x squared equals 5 squared. That's this side here is the 5 squared plus 9 squared, that side there, okay? So that gets us x squared is 25 plus 81. When we work that out, now we're going to simplify that a little bit more and add it up to 106, which means that x itself must be the square root of 106. If x squared is 106, then x must be the square root of 106. Okay? And when we work that out on the calculator, we get 10.3, whatever the units are. Now, I'm just going to go through with you how I got 10.3 to 1 decimal place. That's very important. The calculator actually gave the answer 10.2956. So, what I do is I look at, if I have to express the answer to 1 decimal place, in other words, the first decimal place, the first digit to the right of the decimal, then I look at the second digit. Nothing else, just the second digit, the next digit along. And I have a look and I say, the rule says that if that number is 5 or above, that means I then update the first digit or the preceding digit by 1. That's what I do. And yes, it is 5 or above, isn't it? It's a 9. So therefore I get a yes. That means then I turn that 2 from the 10.2956, I turn that 2 into a 3. And then that is expressed to 1 decimal place. Now, if that second decimal place was a 1 or a 2 or a 3 or a 4, in other words, less than 5, I would leave that 10.2 as 10.2. Do you get it, guys? That's how you do it, okay? So, I can put a box around that. Thank you, Mr. Box. And my answer is 10.3, okay? Do you get it? Good. Now, let's go. Onward, ever onward. Now, we're going to have a look at the use of the same theorem, but we're going to be finding a shorter side now, not just the hypotenuse, okay? So look at this example here. We can see that in this example we're given the hypotenuse and we're given this side here, but this side here we are not given, and that is one of the so-called shorter sides because the hypotenuse is the longest side. So this is the one we have to find, okay guys? Right, let's go. Find the length correct to 1 decimal place of the unmarked side of the triangle at the left. Yes, that's right, and there we go. 1 decimal place is our mission, should we choose to accept it. Now, I've just called that side x for want of something to call it, so I can refer to it in my little equation that I'm going to form in a moment. Okay? I suggest you do the same. So by Pythagoras' theorem, I can say that 15 squared, which is the length of the hypotenuse squared, is equal to 7 squared plus x squared. Okay? Get that? Now, come on, we're going to keep going now. 15 squared with your trusty calculator is 225 and 7 squared is 49. Now, we have to solve this for x. How do we do that? Well, we use exactly the same techniques that we've been using in our linear equations to isolate that x term by itself. So what do we have to eliminate from the side of the equation where the x squared is? Yes, we have to get rid of that 49. So I'm going to subtract that from both sides. And that is what I get, guys. Now, we're down to the final knockout punch. X squared is 176, so therefore what would x be? What you tell me what it would be. Yes, it would be the square root of 176. Okay, trusty calculator, what does that get us? Oh, 13.3, does it? Well, that's pretty good, but I've expressed that as 1 decimal place, but I'm now going to tell you how I got the 1 decimal place. The calculator actually gave me 13.2665. Now, what do? Yes, I want the 1 decimal place. So I look at the next digit along to the right from it, and I have a look and see what is that number. Is it a 5 or above? Well, it is. Again, it is. Okay, so I get a yes for that. Now, what does that mean? Yes, it means I have permission to turn that 13.2 into 13.3. That's it. Okay? Now, I'm comfortable that I've got it to one decimal place, put a box around my answer, and we're done and dusted. We've got it. Okay, happy? Great. Now, let's see what else we can do today. We're working with different units. Now, this stuff is troublesome because you have to be very, very careful not to mix your units up. We've got a situation here where we can see we've got a right angle triangle and we're to find A and we're to express the answer to one decimal place. Now look guys, if you look at that triangle, okay, what have we got? We've got 440 centimetres there and we've got 3.5 metres there. Well, that spells danger. You have to work with consistent units. So I'm going to see what I can do with that. 3.5 metres, if you multiply that by 100 to get centimetres, we get 350 centimetres. Or alternatively, I could divide the 440 centimetres, which is the hypotenuse length, and I would get 4.4 metres, okay? And it's my choice which way I want to go, to work in metres or centimetres, okay? But I have to be consistent. I must use consistent units. So I think I'm going to choose to, rather than work in very large numbers like that 440 and 350, what do you say we just use the smaller numbers, the metres, okay? Let's do that. Okay, let's go. Now we'll use our Pythagoras theorem now because it is a right angle triangle. Therefore, 4.4 squared equals 3.5 squared plus a squared. Good? Good. Now let's just get our trusty calculator going and work with that and simplify the next line. Now, do you know what to do? We have to make a the subject of this equation. So therefore, what do we need to eliminate from the a side? Yes, the 12.25 doesn't belong because we want a on his own. So we're going to subtract that from both sides. Okay? Let's do that. Very good. Now, that cancels, which is exactly what we wanted, and we'll simplify with a clean-up line, and we get that. Okay, guys, now do you know what to do now? Yes, we're going to take the square root of both sides to get a equals the square root of 7.11. And now we remember we have to do this to one decimal place. Now that is the answer to one decimal place, but let me show you how I got it again. The calculator gave me 2.66646. Goodness gracious. Well, I only want one decimal place, so I look at the second decimal place, and I see, is that a 5 or above? Well, it is. So therefore, what is my answer, guys? Come on, tell me. Yes, it's 2.7 metres, because I can update that first decimal place, the 6, to the next digit up, which is a 7. So therefore my answer is 2.7 to one decimal place, and I can put a box around it and everything's good. Get it? Great. Okay, so now we're going to try a practical worded question. Oh, you say, no, it's all right. Have a look at this. A person is stranded in a burning building. Good heavens, how awful. Crying out from a window which is 15 metres above ground. Well, they certainly can't jump. That's too far, too high to jump. If a rescue ladder cannot be placed any closer than 5 metres from the base of the building at ground level, what is the minimum length of ladder needed to make this rescue? Well, give your answer to the nearest metre. Okay, we've got to do it to the nearest whole metre this time, guys. Look, do yourself a favour, and the first thing you should do is read the question again and draw a diagram. I always draw a diagram, and I just happen to have one here. Alakazam, Oh, look at that. A very nice diagram. So, let's see if we can work out what's going on. That shaded rectangular thing to the right is the building, and that area that length that I've just highlighted for you is the ladder. Okay? Do you get it? And I've called its length x because we don't know that, we have to find it out. Okay, so we've got 15 metres high, we've got 5 metres at the base, and we've got x to find out. Do you know what to do? Yes, we notice that the building makes a right angle with the ground. Otherwise, if it doesn't, it must be the Leaning Tower of Pisa or something, because every building makes a right angle with the ground, except the Leaning Tower of Pisa, and this ain't it. So let's go for it. We'll use Pythagoras' theorem, and that tells us that x squared equals 5 squared plus 15 squared. Well, guys, the answer isn't very far away now, so let's do the next line. X squared equals 25 plus 225, thanks to your trusty calculator, and we'll just clean that up a bit and add the 225 and the 25, and what do we get? X squared is 250. Okay, so now what do? Yes, we take the square root of both sides and we get x equals the square root of 250, which is 15.8, according to the calculator. Now, in this case, ladies and gentlemen, what we have to do is we have to express it not to one decimal place, but to the nearest whole metre, okay? The nearest whole metre. So you look at the first decimal place position, which is the one you don't want, okay? So we're saying, yes, nearest metre, so we say 15.8, the 8, the 0.8, that 8 is 5 or above, it qualifies as 5 or above, and therefore we have permission to update the 15 to 16 by upgrading the 5 to a 6. Do you see? Yes, thank you, Mr. Box. That's how you do it, guys. Okay, so there you are. There's some Pythagoras for you, and I hope you enjoy yourself now. You go and do plenty of practice so that you get really good at them. Okay, Pythagoras is actually used everywhere in the world, including builders use it to make sure they get right angles in their buildings when they build them. So there you are, they use it all the time. Okay, thank you so much for listening to my little presentation, and have lots and lots of fun. Thanks again, and bye for now.